consider the function defined on the indicated interval, f of x equal 3 times x plus 3 raised to 2/3 minus 2x over the closed interval from -4 to -2. Find the maximum and minimum values. Solution. In order to find the maximum minimum values, I have to find the critical points of this composite function, right? So we're going to pay attention to the outside function, our function with exponent 2/3. Pay attention to the inside function x plus 3. Don't worry about this number 3 is a constant. Can take that out of our side of our derivative, right? So taking the derivative of this part will be 3 constant outside. Derivative of the outside function 2/3 times x plus 3 raised to 2/3 minus 1 times derivative of the inside function, which is just 1, right? Minus derivative of 2x, 2. So this is the derivative, right? Let's simplify it. 2 times x plus 3 raised to 2/3 minus 1. What's 2/3 minus 1? Well, 1 is the same as 1 over 1, multiplied by the 3, the LCD. 2 minus 3 minus 1 here. Over common denominator, LCD 3. Minus 2, right? 1 times this is the same. So my derivative can be written this way then. 2 over x plus 3 raised to 1/3, right? Raised to 1/3. Notice the sign of the exponent changes. Minus here, be careful there, minus 2. Now, further, I can express my derivative as 2 over cube root of x plus 3, right? Remember, x plus 3 raised to 1/3 is just cube root. Now, I'm supposed to set my derivative equal to 0 and solve for x to find my critical points, right? So we do that. To solve for x, we add 2 to both sides of the equation. We get this. Cube root of x plus 3 equal 2. Now, 2 is the same as 2 over 1. So if we cross multiply, 2 times cube root of x plus 3 should be equal to 2 times 1, 2. Dividing both sides by 2. Cube root of x plus 3 equal 1. Cubing both sides, right, to eliminate the cube root. We're gonna get there x plus 3 equal to 1. Subtracting 3 in both sides, x equal -2. Critical point, x equal -2. Now, remember, critical points are points where the derivative is 0, but also points where the derivative is undefined, right? So the question is there any x such that f prime evaluated at x is equal to undefined? That's the question, right? And in order to answer that question, look at this denominator. Notice if this denominator is 0, 2 over 0 undefined, and therefore derivative undefined, right? So let's set this cube root of x plus 3 equals 0 to see if we can find a value of x such that this denominator is equal to 0, right? And therefore my derivative is undefined. -3, x equal -3. I got another critical point, right? So critical points are -2 and -3. Finally, let's construct this table. X f of x conclusion. X is going to be endpoints here, -4, -2, right? And the critical points in between, -3 here, -3 is already there, right? So we're going to do evaluations at all these input values, right? So let's use our Desmos scientific calculator for that. Remember, the evaluation must be done into the original function, right? This one. So start with 3 times. Substitute x with -4 first, right? Plus 3 raised to 2/3 minus twice -4. First evaluation gives me 11, right? That's what they have to write here. Second evaluation, we have to evaluate at -3 now. -3 here, -3 here. Second evaluation, 6 is what goes here. And third evaluation, to evaluate at -2, 7, right? So let's write out our output values here, 11, 6, and 7. Comparing all our output values clearly, this should be the maximum. And this should be the minimum, right? Minimum.